Hi everybody, this is Mrs. Houts, and I'm just going to make you sort of a short screencast here to go through the first part of Chapter 2, Section 2.1, which is about types of matter. Okay, so matter, the definition of matter is just anything that has volume and mass, so basically anything that takes up any sort of space. It's got to have particles to it. Particles is a word we talked about a little bit in that POGIL that you did. I think of a particle as just any sort of single little piece of something. A particle is a pretty generic word. And we'll talk more about particles as we go along here. And so matter is made up of particles. And also remember from your physics, if you had physics, that mass is not the same thing as weight, okay? Weight depends upon gravity, right? Or acceleration due to gravity. In physics, we use newtons to talk about weight, which is a force, the force of gravity, the force that's put down by the mass of something. In English, we are pounds. Force is newtons in the metric system, but for mass, we are going to use grams or kilograms, sometimes milligrams, some type of gram is our unit for mass. Okay, and matter can be categorized as shown on this flow chart. Okay, we can have pure substances, we can have mixtures. You can divide the pure substances into elements or compounds, and you can divide mixtures into these two kinds of mixtures, homogeneous or heterogeneous. And so we're going to go through all of these possibilities. All right, pure versus a mixture. A pure substance is when every single particle in a sample is the same exact thing. Okay, a mixture is if you have more than one type of matter together, in your container or in your sample or, whatever. Pure things can be either elements or compounds. So for example, if you had a pop can made out of aluminum, and if every single atom in there was an aluminum atom, that would be a pure sample of an element. Okay, and the element would be aluminum in that case. Elements are just all the things on the periodic table that you have learned about in the last unit. Okay, a compound is when you have more than one kind of atom bonded together. And we're going to talk a lot about bonding as we go along here, but basically all it means is that they're held together. So for example, water is a compound. Its formula is H2O. So it has hydrogen atoms and oxygen atoms held together. So that's a compound. And if you had a glass of water, of only water, you would have a pure substance. You'd have a pure collection of water. Okay, so the word pure, all it means is that everything in there, in your sample, is exactly the same. Okay, and it can be a single element or a compound. All right, here's just a little bit more about elements. Okay, they're off the periodic table. If you have a pure collection of an element, every single thing is an element. Like for another example, you could have a piece of copper metal. Okay, sometimes you see copper, and every single atom in there is a copper atom. A compound, again, is when there's two or more kinds of things bonded together. In this sort of generic picture, I got two little blue circles and one red circle. So here the blue would be one kind of element. The red would be a different kind of element. This actually could be water. Those could be hydrogens. We'd have two hydrogens and one oxygen. Okay, but in this sample, every single one of those things is exactly the same. Okay, so this would be an example of a pure compound. All right, and the way to get these blue and red circles apart from each other is chemical. You can only do chemical methods to break the bonds that are holding that thing together. Okay, so we're going to talk more about that too, chemical versus physical. In this case, I have a glass of water. I can't pour out the H's and leave the O's behind. If I wanted to separate those, I would have to do some chemical thing to it. All right, mixtures can be classified as either homogeneous or heterogeneous. And a homogeneous mixture means if you look at your mixture, you can't tell that you have different things in there. Okay, remember, a mixture is when you have two different kinds of things together. So for example, if I had a glass of Kool-Aid, that I had made with water and Kool-Aid powder, that Kool-Aid's going to dissolve, and I'm not going to be able to look at my glass and see, individual sugar molecules. Okay, it looks all the same. You can't tell by looking at it that you have more than one thing in there. Okay, that's homogeneous. Homo means the same. Okay, if you have a heterogeneous mixture, hetero means different. And that means if you look at a mixture, you can tell by looking at it that there are different pieces in there. Okay, one example we use a lot is if you have a glass of orange juice with pulp. Okay, so pulp is just the pieces of the orange that are still in your juice. If you look at your glass of juice with pulp, you can see the solid orange pieces floating around in there, and it isn't clear to just look right through it. Okay, another example of a heterogeneous mixture is if you've ever seen a piece of granite. You can look at a piece of granite and see all the different kinds of rocks or stone in that. So that would be a heterogeneous mixture. Okay, it's different, and you can look at it and tell. Okay, so mixtures are not pure. Okay, there's more than one different kind of thing in there. In this example, I have these big blue circles. So those are elements. Those are just single things, not bonded to anything else. And then I have this one again, where these are bonded together. So this is a compound, and this is an element. So this mixture has an element and a compound. So this is a mixture of an element and a compound. And mixtures, depending on what kind of mixture you have, can be separated either chemically or physically. And again, we're going to talk more about that in detail. But if I wanted to get this one, the compound, away from the element, lots of times I can do that just with some physical method, maybe filtering, okay? Or I would have to do some chemical thing, but we'll talk about that again later. All right, so mixtures can be lots of different kinds of mixtures. You can combine solids, liquids, and gases in lots of different ways. One example of a solid mixture would be like a Advil or an aspirin or something. Usually there's definitely more than one kind of compound in medicine. You can have a mixture of a solid and a gas. That candy, sometimes people eat, Pop Rocks, that's got gas inside of the solid, so that's a mixture. You can have a solid liquid mixture. You put an ice cube in a glass of water, you have a solid ice cube and liquid water. That's a mixture. You can have liquid-liquid mixtures. If you have some lemon dissolved in water, okay, that's a different kind of mixture, or lemon juice, I should say. You can have a gas-liquid mixture. Carbonated water has got CO2 gas dissolved in the water, so that's a liquid and a gas mixture. And you can have a mixture of two gases, so air is for sure a mixture. We're not breathing pure oxygen. Air's got nitrogen, hydrogen, oxygen, lots of stuff mixed in there. So there's lots of different ways to make mixtures. Okay, and again, those mixtures might be heterogeneous or they might be homogeneous. All right, so let's do this practice page here and see if you can figure out if these things are elements, compounds, mixtures, and if you think it's a mixture, is it a homogeneous mixture or a heterogeneous mixture? All right, so pause the video if you want to and think about it for a second, because I'm about to show the answer. All right, aluminum, this is straight off the periodic table, so that's an element. A piece of copper pipe, again, is straight off the periodic table, so that's an element. Concrete is made up of this compound, this compound, plus other ones. And usually if you look at a piece of concrete, you can tell that there's different things in there. So that is a heterogeneous mixture. Carbon tetrachloride, you don't have to know what it is, but you can tell that I didn't list anything else here. There's only one thing listed. So this would be a pure compound. And then a sports drink, it's got water, it's got sugar, it's got another kind of sugar, it's got salt, it's got all those different things in there. So it's for sure a mixture. And if you look at your sports drink, It looks uniform throughout, looks the same, it's clear. You can't see pieces floating around in there. Hopefully, if you can, I wouldn't drink it. Okay, so that is a homogeneous mixture.